Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Blurry. Alright. That's a little better there. Okay, folks, who's in the room? I see 6. Okay, Sierra, thanks for checking in. Joe's in the room. Joe and Sierra. 4 more. Jay's in the house. Yeah, this will be Jay's first time taking taking the test, and he's pretty sharp. He's a pretty sharp guy. I worked with him a couple times, and I think he'll do well. But we'll see and take it from there. Okay, okay, actually, okay, Layla, I was just about to post your question. Just about to post your question. From South Korea. It's good to know I'm global. I'm global. Well, I've worked with people in Kuwait, South America, all different countries. So give me 1 second, and we will get this question up. All right. Okay. Okay. Okay, I'm going to type this in. And it's coming, guys. Be patient with me. Okay, here's our question. I'm not even going to, hold on. Okay, there's a question. A car traveled at 60 miles an hour for 2.5 hours. If 1 inch equals 20 miles on a map, how far has the car traveled on the map? Not OB, but on the map. Sorry for the typo there. Okay, so this is how we handle word problems. Alright. First, we look at our car. It's traveled 60 miles an hour for 2.5 hours. So here's our car. And it's moving at 60 miles an hour for 2.5 hours. So we have 1 hour, 1 hour, and 1/2 an hour. Okay, so we have 60, 60, and 30, which it travels 150 miles. All right, 60, 60, 120, 30. All right, 150 miles. Now, what the question is stating is that there is a, what's the word? A scale. There's a scale. All right. So, 1 inch equals 20 miles. All right. 1 inch equals 20 miles. Okay. So, they want to know how far this vehicle has traveled on the map. All right. So, I can look at this. 20 miles. What are our answers? It's 7.5 inches. I can see it because 1 inch, if 1 inch equals 20 miles, then we take 150 miles, it would be 7.5. And how you test it is, I put 1 over 20, so 7.5 inches equal 150. If we cross multiply these two, we'll get the same result, and that's how we test it. And I'll test it. 150 times 1, we know is 150. The harder one to figure out is the 7.5 inches times 20, because 1 inch, 20 miles, and 7.5. Now, here's a rapid math technique. 7.5 times 20. Don't deal with that. Just deal with 7.5 times 2. 2 times 5 is 10. 2 times 2 is 14, 15. And then we're going to add the 0 back that we didn't have here. So we add the 0 back, and then move the decimal in one place because the decimal point is there, and we will come up with 150 miles. Alright, and I hope that satisfied you, Layla. If it did, please let me know. And I understand there's a time delay, so I will wait, and after that, I'm going to look into another question. And also, was it clear, Layla? Let me know if it was clear. And everybody in the room, if that was a clear explanation, please let me know. If I need to break it down more, let me know. And we have 11 people watching. Please hit the like button. Is it blurry for any? Is it just a coincidence? It was looking kind of blurry to me, and okay. Alright, William, how much pure acid must be added to 12 ounces of acid? Alright. I'm seeing the stream alright. Okay. Alright, great. Okay. Okay, William, I'm going to work out your problem. It's looking clear to me. Maybe it might look a little clear, Jay. Maybe it might look a little clearer if you, I don't know. You could blow up you could do the full screen thing. Maybe that may help out. Okay, Mr. Morgan. Okay, how much pure acid must be added to 12 ounces at 40% in order to produce a 60% acid solution? Okay, when I do mixture problems, I work in containers. Alright, so I have a container 1, and I have a plus, this is a plus sign in the middle, and there's container 2, and it's going to equal our new container, which is going to have a new number of units, ounces, liters, pounds, whatever. And then this is how it works. Alright, the percentage, and then I have DEC for decimal, and then I have QTY. Again, percentage, decimal, QTY, which is quantity, is going to equal a new percentage, which turns into, you can turn into a decimal, and a new quantity. Now, here's how this is going to work. We're going to go vertical, and then we're going to go L-shaped. Okay, and I will explain this. All right, because it takes a while. You have to do a couple of these to get it. All right. So what I mean by vertical, percentage times quantity plus percentage times quantity equals the percentage times the sum of the two quantities. All right, so let's take your question, Morgan, and plug it in and plug in. All right, and everybody, make sure you write percentage decimal quantity, and make the plus sign in the middle, and then percentage decimal quantity. Now here we go. Now the initial is 12 ounces at 40%, so that is the quantity. 12 ounces, 40%. And the decimal form of 40% is 0.40. Now, how much must be added to, how much pure acid must be added to 12 ounces at 40%. So now, this is the additive, the 100%. In decimal form, this is 1.0. All right, and quantity is unknown. We are going to put a X here, and then the new percentage, we're going to put 60%. So 60%, the decimal form is 0.6, and the quantity is going to be it's a 60% solution. All right, William, did they give you a? I'm gonna look at this because normally they give you like a new quantity, but it's okay. We won't panic. We'll work our problem. All right. So here's our 0.40, 40% times 12 ounces plus 1, which is 100%, times X. We don't know how much we're going to add. And then we need a 60% solution. That's what we're going to wind up. So we have 0.6 times the sum of 12 ounces plus X. There you go. That works. Because we have an unknown. We don't know how much this is, but it's going to produce 60%. So we need to multiply 40.40 times 12, 0.8040, 480, 2 decimal places, 1, 2. So this is going to be 4.8 plus 1x is equal to 12 times 0.6, which is 72 decimal. This is going to be 7.2 plus 6x, 0.6x. My apologies. And you have to be very meticulous about this, because if you go off, it's going to throw you. So after that, all we really need to do is combine like terms. Alright. So we can forget about that. And we have 4.8 plus 1x equals 7.2 plus 0.6x. So the 0.6 is going to jump the equal sign, and we're going to have 0.4x. The 4.8 is going to jump to that side, and 7.2 minus 4.8 is going to be 2.4. So 2.4. Now what we need to do is solve for x by dividing 0.4 on both sides. This one cancels out. So 0.4, 2.4. We have one decimal place out here, so we got to move this over one, and we move this over, and we raise this up for our answer. And the answer is 6. So we're going to have to add 6 ounces to this. We're going to add 16 ounces. New quantity of solution is going to be 18 ounces. So it's very, very important when you work in the question. Percentage. This is how you're going to work it. Always. Vertically plus the vertical equals the L shape. And in the L shape, we tie in the two quantities. So whenever I'm looking at my original mixture plus the added mixture, and we want it at 60%, all right, I always write decimal. I write the percentage, but I also write it in decimal form so I don't get lost. So again, vertical plus vertical equals the L, which is the percent, and the L is the sum. So when I look at this, 4.4 times 12 plus 1 times x, because we didn't know this at first. We found it after we calculated. And then 60%, 0.6 times, this was x again, so 12 plus x. All right, so this is the original formula that we made from my construct when dealing with mixture problems. All right, now I know that probably is not clear to everybody, but this is DVR, and so you can look at it later, and you can pause. You can pause and go through it slowly. But my method is percent quantity plus percent quantity equals new percent of the mixture plus or multiplied by the sum of, in parentheses, the two quantities. If we don't know what the quantity, when they're asking, well, how much are you going to add, then that becomes x. All right. And even when we came down here, when we used our vertical multiplication method, it was 1 times x, because it was an unknown. We didn't know how much we were going to add to the solution, and so that's how you work that out. Thank you for that question, Mr. Morgan. All right, the quantity is 12 because you're only adding acid. Okay, probably just my screen. Okay, the quantity is 12 because you're only adding acid. I don't know what that meant, Sierra. Do you have it, Sierra, or are you confused? And I know there's a time delay, and that's all right. I will wait. Okay, I'll explain it. Okay, William, he says, great explanation. Everybody else in the room, was it clear? That is my main focus. Was it clear? Everybody type clear if it's clear to you. Alright, and if that's clear, I see 1, 2, 3, 4, 5 clears. Okay, 1, 2, 3, 4, 5, 6. I'll take the 6 clears. Looks like, alright. So, alright, let's check the email. Okay. Joe has sent a mechanical question, and I'm twisting my head, not because I'm crazy. Very good question, Joe. And I'm going to solve it for you. Okay, I'm going to type it out. Matter of fact, help me out, Joe. Type out that whole question for me. Hey, Jordan, how you doing, bud? And hopefully Joe is typing out that question so everybody in the room can see it. And we'll move right along. Okay. And actually, well, it's in book format. All right. All right. Okay, guys. What effort must be exerted? Okay, thank you, Joe. Okay, now, so what effort must be exerted to lift a 60-pound weight in the figure of the lever shown? Disregard the weight of the lever in your computation. The answers are 30 pounds, 32 pounds, and 34 pounds. Now, when you are dealing with levers or levers, lever or lever, levers or levers, there's 3 classes. Let's start with that. There's 3 classes. The class we're about to talk about is where we have a downward weight, 2 downward weights. It's like a seesaw. 2 kids are in the weight, but we would call this the effort, and we would call this the load. or we could switch them. The effort could be one side. The only thing is that the vectors, and these arrows are called vectors, they show directions of force. All right. And in the middle, we have something, the little teeter-totter thing here is called a fulcrum. A fulcrum. All right. Now, we have a second class lever. This is one, first class. The second class, the fulcrum is here. We have the plank here, and the load is here, and the effort is here, but it is in a upward direction. All right. The third class, same situation or very similar situation, but the effort is applied here, and the load is applied here. All right. So what we have in this question is a first class lever in this question. And like I said, this is DVR. You can look at this later. You know, this will be available if you subscribe to me. Even if you're not subscribed to me, I hope you all do subscribe to me. But if you're not, it's still, if you look up Kieno and look at the live streams, my live streams, this will be on it. So, let me zoom in. I need to zoom in on this because I can't see the. There we go. I can't see the distances. I see A, and then I can't see the distances, Joe. Is that an 8 in there, Joe? If that's an 8 in there, just let me know. And it looks like there's an 8. It looks like an 8. So, okay, guys. This is how we work this problem, okay? You have the fulcrum in the middle. All right. You have a plank. Okay. So you have the load on this end, the fulcrum here, and the effort is going to be applied here. All right. So now what we have is a 60-pound weight. And it appears to be 8, let's say feet. Let's say 8 feet away. All right. So our answers are 30 pounds, 32 pounds, or 34 pounds. 30 pounds, 32 pounds, or 34 pounds. Now, this is how I need you to look at these questions. Think of the fulcrum as an equal sign. All right. And we have a new word we're going to learn called load moment. Load moment. All right. So the load moment is a function of distance and weight. So we have a distance of 8 feet and a weight of 60 pounds. 8 feet times 60 pounds has a load moment of 480 foot-pounds. All right. Now, in order to get this to balance, all right, we're going to have to exert the same amount of foot-pounds. And I see A here, but I don't see a number. I couldn't see the number of feet on that end. It just says A. What is the distance of A? That is crucial. That is something that you must know. So this is kind of like not like a. It's really not a complete question. I wonder what book this is. Because you have to know the distance of A in order to know how many pounds. So, anyways, I'll just if we're going to use 32 pounds, which it looks like you made that answer in your book, but if you're going to use 32 pounds, the distance must be such that you multiply that distance by the pounds and come up with 480 foot-pounds. So just for speed purposes, because I know this is a little bit of a lengthy explanation, 480 divided by 32. This means that 15 feet, if we're going to have 32 pounds be our answer, then A has to be, because he has A here for distance. Alright. And A would be 15 feet if we're going to use 32 pounds. Alright, because 32 times 15 equals 480 foot-pounds. Alright, so that's why the fulcrum is the equal sign. But if we're going to have 8 feet and 60 pounds, we have produced a load moment of 480 foot-pounds. And then 32 times 15 is 480 foot-pounds. So the system balances out if we think of it as an equation. And load moment is a function of distance and weight. Just like this load moment is a function of distance and 32 pounds of weight. Alright? If we assumed it was even, what if we assumed it was even? You should never assume it was even, because you get yourself in a pitfall. They needed to label this. They needed to label this. Alright. I'll give you another one. And I'll give you, I know, Joe, you said no values are given. Could you tell me what test prep booklet that was so we can all avoid that? Okay, but I will give you a couple of good examples how the question should be worded, and that could have just been like a typo or something like that. All right, so let's give the room a question that let's give the room a question, okay, that we can work with. Is it a mod 1? No. Okay. Here's a question. All right. I will draw a diagram, and then I'll type out the question. Well, what we have here is a fulcrum, and we have a pry bar, and we're going to place an 80-pound weight here. And so we have some large object that we are trying to lift. Alright, but there's 1 foot here, and there is 4 feet here. So, we want to know the force that this is going to create. Alright, so let's type in the question, shall we? Alright, here we go. Let me get over here. Alright. Now, a pry bar is used to move a concrete block. A force of 80 pounds applied. Tipping force on the edge of the block of All right, and our answers are 80 pounds, 240 pounds, and 320 pounds. Okay, now, if anybody in the room, based on the previous example, knows it, you guys can just spit the answer out. But what I'm looking at is they want to know what is the tipping forces that this is going to produce. Again, the equal sign is under the fulcrum, and we have to look at the two load moments. If we're going to have a balanced system, the load moments must equal each other. So, when they're multiplied, and it is a function of distance and feet and weight, or foot, we call it foot pounds, but it's foot times pounds, which will produce foot pounds. Alright, and on both sides, foot times pounds, which will produce foot pounds. Okay, so the equal sign's in the middle. We have some unknown information here, all right, but the known information. So that's with that other question. You didn't have both of the distances. You had to at least have both of the distances in order to figure out one load moment. At least I haven't seen a question where they just said, "Oh, well, we'll give you this distance, but we're not going to give you this." That's why that question was weird to me. Very good, Joe. So 80 times 4 is 320 foot-pounds. So this has to have a force. This will produce a tipping force of 320 because 320 times 1 is 320. So 320 is there on this side for a load moment, and 320 is there for the load moment as far as tipping force. All right. Good job. Good question. All right, let me back up, and you have a text document. Oh, sent from my iPhone. Okay. All right. Alrighty. Alrighty. Copy. Paste. Okay. And let's see here. Inbox. Question for the live stream. Okay. Okay. Okay, so we have an electricity problem. And before I move forward, okay, give me a second, Layla, I will get to that. All right, we have an electricity question. All right, in this question we have a battery, we have a resistor, and we have another resistor. And I probably should have just brought my conductor down. And we have another resistor. Alright. Now, if, and what they have here is point A and point B. Alright. And I'm going to answer the first one. If I run out of questions, I'm going to come back to this, because I want to give everybody in the room a a chance to, ask questions and kick them out. So I'm going to be jumping around with the questions. So here's the first question. If the current leaves the battery, current's leaving the battery in this direction, what is the direction of the current and resistor X? Well, if the current is leaving in this direction, it's a closed loop. This is what we call a series circuit. All right. So it's going to flow across, and this is resistor X. I'll put RX and RY. So it's asking, if the current leaves the battery in a direction shown, what is the direction of the current? A, B, or there is no current in the resistor. Well, they haven't really assigned your battery source voltage, but they show a direction of a current. So that I'm under the assumption that there is some type of voltage there. All right. The voltage drop is going to be the same across each resistor, which means, let's say we have 5 volts in this system. All right. Well, the thing about voltage is, if we have 2 voltages, hold on, 10 ohms, 5 ohms, 10 ohms, 5 ohms on the bottom, 10 ohms on the bottom, 10 ohms in the top, 5 ohms in the bottom. Okay. That is going to be an issue a little bit. Okay, so here's my memory aid here. There's my pyramid. And we have a V, we have an I, and an R. V equals voltage, I is current, and R is resistance. So, but the only thing is they didn't give you, it really doesn't matter if they didn't assign voltage, but I would just assign voltage just so I could physically or literally see how the numbers are going to play. So here's a circuit, and for you in the room that aren't really familiar with electricity or electrical schematics, this is a battery symbol, plus or minus, or I shouldn't say battery, I should say a power source. A resistor resists current. All right, it kind of slows down the voltage, resists. I was about to say resists the current. So we have a stronger resistor here because resistance is measured in what we call ohms. Current is measured in amperes or amps. Resistance in ohms, and voltage will be V. So whenever we want to find voltage, all we need to know is we could know the current or the resistance. All right. And so when we want to find voltage, if I want to find current, I cover the I, which is current, and I will divide voltage by resistance. If I want to find resistance, I'll cover the R, and I will take voltage and divide by current. If I want to find voltage, I'll cover the V, and it is current times resistance in ohms. So let's just say, if I was on the test, I would just assign this 5 volts anyway. Just give it 5 volts. Or, you know what, let's give it 10 volts. Because 10 is a much easier number to work with. So we give it 10 volts. Alright. Now, if I want to know the current in this situation, alright, I would cover the I, and it would be voltage divided by resistance. Alright, so voltage divided by resistance would give me a current of 1 amp. Because we covered this, voltage is 10, resistance is 10, that equals 1. We come around and we look at the current at this point, and it is voltage and 10 over 5, which is 2 amps. Now, why do we have 1 amp here and 2 amps here? Because the resistance is twice as strong. It's resisting. It's kind of choking or slowing down the current, if you would. So we got that by 10, which is the voltage, over 5. Alright. So we have 2 amps at this point. Alright. And the voltage drop is going to be greater across this resistor. it's going to drop the volts because the current is much stronger. The resistance is much stronger. 10 amps means it's twice as strong as this guy. All right. So, is anyone experiencing the static? It's really rough for me. No static for me. Sorry, try upping the quality. That helped for me. Okay, yeah. Alright. Email when you have time. Alright. So, okay, moving right along. Okay. I don't know what that static is, guys. I kind of tested it out, in the test run, and I didn't hear any static. So let's see. Try upping the quality. Use Jay's method if you're in the room and you can read. All right. So that's that. That's DVR. If you need to. All right, I have 12 watching now. 6 likes. Up those likes, please, for me. All right. The price of gasoline rose from $2.90 to $3.08 per gallon. What was the percent increase? Very small. Now, and you have to look at these, Layla. When you look at these questions, the price of gas rose from $2.90 to $3.08. So we'll put initial price, final. Initial price was $2.90. The final price is $3.08. So first we have to look at the initial price in order really to determine the increase. All right. So if I just want to roughly gather the number, $2.90, 10% of that is, we just define 10% of any number, move the decimal point over. So it's like 29 cents. All right, 10%. Just use that as a baseline because they're saying 3.2%, 6.2, 6.4, 10.6, and 1.6. All right. So if this is 10%, we move it over another decimal point, and it would be like 3 cents. That would be 1%. All right. So 3 cents would be 1%. We started out with $2.90. We wanted to know 10%. We move it over 1. We want to know 10% of that, 1% of that 10%. We move it over again. 0.029, which rounded up is, this rounded up to make that 0.30 or 3 cents. All right. So 3 cents is the 1% mark in this case. So we look at 290, 10 will get us, 10 cents will get us to $3, another 8 cents. So this is 18 cents. This is, we added 18 cents. So it appears to me the closest we could get is 3 cents. So this is multiplied by 6. I would tend to I would lean towards 6.2%. Because each unit, hold on, 3 cents, hold on, 3 cents. Units of 3 cents, which is the 1%. Yeah, 1, 2, 3, 4, 5, 6. 18 cents is 6%. Is around 6%. I would lean with the 6.2. Another thing we could do is we could use the is over of, and we could say 3.08 is what percent of 290? $3.08 is what percent of 90? We could find a percentage, 100. I'm sorry guys, not enough hands. Alright, so I'm going to grab my, you would do this by hand, of course, because on the military aptitude test you can't. But basically 308 times 100, move the decimal point over to 308 for our answer, and then we would have 308 divided by $2.9 or $2.90, and the answer I get is 106.2, which would be 106.2%. So it meets the 100% and increases by 6.2. So both of my methods work. I was just giving you more than one way to skin that cat. This is what my grandma used to say. It's more than one way to skin a cat, which means there's more than one way to do something. So I could either take this decimal point, move it over 2, come up with 3 cents to find out what the 1% is, and then 18 cents was what the increase was, and so I came up with 6%, but 6.2 was the closest. Or I could use my is over of method and find out that we put this up top because $3.08 is what percent of $2.90. And I put the X for the unknown and 100 on the bottom. You cross multiply, divide by 2.9, and I got in my calculator 106.2, which means that it met 100% of 290 and then increased. So you have to look at this as 100% plus 6.2. That's how you have to look at that. So it met the 290 and it increased 6.2%. Okay? Just type in clear if everybody got that. Okay, room. Let's see those clears. Okay. Okay. Checking the... Okay, we have another electrical question, and here we go. Now, what we have are two types of electrical circuit arrangements. One is called series, the other one is called parallel. So, I'm going to put my battery on this side. I like my battery on this side. But we're going to have 2 resistors. Okay. And then we're going to have another battery. But we're going to have two resistors. This is the series arrangement. And this is the para. Okay, so these circuits, these resistors are arranged in series. These are arranged in parallel. All right. So, and this comes up a lot on the military aptitude test. All you need to know that is this is the weaker. This provides less resistance. This is stronger resistance. Resistors are stronger when they're one behind the other, not when they break off in paths. Because electrical energy just kind of, they get weaker when they're in parallel. Okay. Why is that? Well, resistance and series, and I'll put R sub series, So let's say this is a 5 ohm resistor, and this is a 5 ohm resistor, and this is a 5 ohm resistor, and that's an omega symbol. This is a 5 ohm resistor. Alright, resistors in series is this. For total resistance, it's going to be 5 plus 5, which would be 10 ohms of resistance. Alright, now just based on the parallel arrangement, this is what happens mathematically. I'm going to put R para for short. Alright, R parallel is actually 1 over R parallel, so we get 1 over R1 plus 1 over R2. So naturally, if we have 1/5 plus 1/5, that's going to be like 2/10. Alright. And so we can see just by arranging these, and the 1 over R1 plus 1 over R2 dot 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 dot, which means if there was more, it'd be 1 over R3 if we added another branch to this system. Alright, so that's one of the basic things that you need to understand about resistors and how they're going to act. So if the two resistors and battery are arranged in each of the above circuits, which circuit arrangement has greater resistance? The series circuit has greater resistance every time, because you can see how the numbers play out. If we calculate resistors in series, it's 5 ohms plus 5 ohms is 10 ohms. And parallel, it's 1 over R1 plus 1 over R2. So naturally, it's not even anywhere near. It's not even 1 ohm of resistance. All right, where this is 10. All right, just type in clear if everybody gets that. If you don't understand, just let me know, please. All right, moving right along. Man, this thing is flying, man. I never thought that an hour could go by so fast. Wait, Kieno. 1/5, 1/5, 2/5. Okay, my bad. I get a question wrong twice a year. But my point is, it's still less than 1. All right. Clear. Second, Sierra's comment. Okay. All right. So, it's still not 10 ohms. So, even though we have a 5 ohm resistor, 5 ohm resistor, when we put them in parallel, the resistance is going to be dropped considerably because they are placed in parallel. All right. So, thank you for catching me on that, Sierra. All right. All right. Come on, Gmail. Okay. Alright, I gotta hit, let's see here. I don't know what's going on, guys. The system's kind of running slow. Joe, it looks like you sent a question, but I don't see it. Just resend it. I tried to look at it. And alright. Mr. Velez has a question. And it's moving slow, I apologize. Alright. right, Mr. Velez, the one question you have with the 300 volts, when we link up again, that is a long explanation for this. Can you do a hard factor question that is on the ASVAB? All right, Navy lady, welcome to the stream. Which of the following is correctly decided the flow of water through exit pipes? Okay. Wow. Two more nickels and dimes. They want to how many coins each does she have? Alright. Tash. There's a pile of marbles. Oh, okay, that's a second question. A girl has 2 more nickels than dimes and 3 more quarters than nickels. And it's all going to be equal to $3.35. How many coins of each kind does she have? Alright. Let's do a word problem. Okay. 2 more nickels than dimes. Alright, so we have nickels, we have dimes, and we have quarters. And they're all going to equal $3.35. So what do we know? We have 2 more nickels than dimes. So dimes are a certain amount. So we have 2x and 3 more quarters than nickels. 3 times 2x. So 2 more nickels than dimes. Uh-oh. There's a mistake. 2 plus x. 2 more nickels than dimes, not times. So this is 3 times the quantity of 2 plus x. And all that is going to be equal to. So what we're going to do is, what I've done is I've centered on dimes because you have to have a median or like a starting point. And so dimes, we have 2 more nickels than dimes, and then 3 more quarters than nickels. So this is a plus 2. 3 more quarters than nickels. 3 more quarters than nickels. 3 and 3 more quarters than nickels. Alright. 3 more quarters than nickels. How would I express that? 3 more quarters than nickels. And if anybody in the room wants to help me out, you can. 3 more quarters than nickels. 2 more nickels than dimes and 3 more quarters than nickels. 3 more quarters than nickels. Alright. Will we express that 3 plus 2 plus x? I haven't seen a question like this in a long time. I'll show you normally what I do get, which is more likely you'd see, but I want to just see if this works. 2x plus x plus 5 plus 5 plus x. And then 7x, no, 2xx, 4x plus 5, 3, 5. Now, I don't think this is gonna work. I'm gonna do some research on this question. Normally what happens is most of the, from my research, this is gonna be like, let's see, 265. It's 4 divided by 265. This is not an even number, so that's probably not gonna work. Normally what I get are questions like, and this is probably one of the hardest of word problems. I'll do some research on that and get back to you guys probably by next week. Alright, but normally when we get questions like these, there'll be like a piggy bank question. Like you would have a jar of coins. Alright, so there are 39 coins. Some are pennies and some are dimes. Alright, so we have a jar, and we'll put P for pennies and D for dimes. Alright, so the question will say you have 39 coins. Some are pennies, some are dimes, and the total value of the coins is $2.55. Alright, so what you have to do, this is like solving a system of equations. Alright, and you have pennies plus dimes. We identify the actual coins, and we place 39 next to that. Then the penny we have to value after, so we ID on one line, and then we value on the second line. Alright, so we have 0.01, that is the quantity, or the sum, that's what a penny is equal to. And a dime is 0.10 D equals $2.55. Now the thing about I'll get rid of this because we have all the information up there. The thing about a system of equations is we have two variables that we're solving at the same time, simultaneously. So what I would do is I would manipulate one of the equations. How do I manipulate the equations? I will multiply one of these equations by something to change, and the top one is the easiest one to change. Alright, I will manipulate it by multiplying by negative 0.01 P, or not P, but negative 0.01, because what's going to happen is I'm going to wind up adding vertically in 3 columns, here, here, and here, and I'm going to isolate. So I'm using negative 0.01 so I can isolate dimes. I will eliminate the pennies in the equation and then solve. Alright, so here we go. Negative 0.01 times P is negative 0.01 P, minus, because this is going to be multiplied by Z, 0.01 D equals 39 times 0.01. So I'll just do the math right here. 0.01 3900039, and then the decimal comes over 2. So 0.39 or negative 0.39. Sorry about that, folks. So now what is going to happen is we're going to add vertically. The reason why I used negative 0.1p and made it negative because we're going to forget about this middle the ID equation because we've manipulated it by multiplying it. So that when we add vertically, we eliminate the p's because negative 0.01p added to 0.01p is going to be 0 pennies. All right, but now we have to deal with this. We isolate dimes, so we this will be 0.09d. All right, and then we take the negative 39 cents and we apply it to the $2.59. So immediately I'm thinking 40, which will be $2.15, and then $2.60. Now I didn't put 39 under there. I just said, okay, it's closest to 40. So I subtract 40 in my head. 40 minus 55 is $2.50, and then we add the penny. That is a rapid math technique that I use. All right. So now 9 is going to be divided by both sides, and we will find the number of dimes. 0.09, 0.09. These cancel out. D is going to be equal to 0.09 and 2.16. The thing is we got to move this over 2 decimal points and this one over 2 decimal points. 9 goes into 21 2 times, which is 18. And then we're going to get 3, the 6 comes down, and 4. So we have 24 dimes. All right. So if we have 24 dimes, we're going to erase that. If we have 24 dimes, then 24 minus 39 will give us the number of pennies, and which is going to be 15 pennies. All right. Now we could also test this. All right. We test this by, and we can erase this because this was our manipulation of P plus D equals 39. So we get rid of that. But now we understand we have 15 pennies, 24 dimes. 15 pennies is equal to 15 cents. 24 dimes is equal to $2.40. All right. Now we have to see if this is equal to $2.55. What is 240 plus 15 cents? $2.55. All right. Now this is DVR. I know that was a lot. I know it was a lot. You know what I'm saying? But you have to use the systems of equations method in order to solve that word problem. Those are one of the hardest math problems that you will encounter. And you should move at a pace, because this is a time test. You should move at a pace where, now, my thing is this. It is good to know how to get through this. But 9 times out of 10, remember, multiple choice. You are operating with a multiple choice question, multiple choice test. So would I go through all of this? If it was absolutely necessary, yes, I would. But if question A was 16 pennies, 4 dimes, and answer B was, I don't know, 25 pennies and, I don't know, 10 dimes, and then we had 15 pennies for an answer and 24 dimes, okay? What I would do is I would calculate the pennies and the dimes in each question and see which one closely comes up to 39. All right. And then I would take the 15 pennies, the 24 dimes, and add it and see if it got to 255. So I showed you how to come up with it, but you have to decide what method you're going to use because you're operating in the element of time. So I show you how to execute it, but sometimes we can just pull the answer out if it's a multiple choice question, which this is a multiple choice question. And And just 1 minute 5 seconds to answer questions. Yeah, so that's what I would do. I would probably just, I showed you how to do it, but I would probably play with the multiple choice answers in order to get it. If everybody's clear on that, please type clear. And I'm hunting down another question. Okay, in the same question, velocity of block Q above the ground. In the same question, the velocity of block Q when it reaches the ground, the height 7 meters above the ground is 30. Okay, I'm not really sure. This question is from Kate. I'm not really sure what I'm not really sure what, because it looks like it's a part 2 of a question, but nonetheless, I'm not sure if you're looking for angles or I'm not sure if you're looking for sides. Alright, but what we have, folks, is we have a triangle that looks like this. Alright, it looks like this, and there is a 30-degree angle in here, and then there's 8 centimeters here. And I'm not sure if, well, this looks like it's not equilateral, but the two sides are the same. So this is 8 centimeters as well. And if I wanted to define the angles, the total angle of a triangle is 180 degrees. Minus 30 would be 150. And so 75, this would be 75 degrees, and this would be 75 degrees. This was not. All we had was the 30 and the 8 centimeters. So I know this is 8 centimeters, this is 8 centimeters, and this is 75, and this is 75. But I see the triangle, and then there's 1, 2, 3, 4. So, and then I see question number 16, and it's like the answers are cut off. Meters per second. And the same question, block Q, when it reaches the height of 7 meters above the ground. Alright, I'm going to need some more information. That's the only part to the question. Okay, to finding the angles or the sides, or because I saw a question like this where 2 planes took off a carrier and they split up 15 degrees. One turned 15 degrees this way, the other one turned 15 degrees that way. And then, it was like, okay, and then they went. That's what this question literally reminds me of. So, stretch my legs a little bit. Alright, tell me if you need more. But, that's where we are at. Alright. It wants mechanical advantage of the wedge. Oh, okay. All right. Okay, that's what it was. I thought you were just looking for the sides. Okay. So yeah, I didn't see that part in the question. And let's see here. Okay, then that's a whole different. Okay, guys, hold on 1 second. I'm sending some more links out to people that are like, oh, where's your live stream? So you can come in. The more. Okay. Okay. Now, that changes the game, girlfriend. All right, the mechanical advantage of a wedge. All right. 8 centimeters. I'm trying to give you guys. I'm looking for one of my. All right. What we're gonna have to do is we're gonna have to determine the length of the total, not the side, because this side 8 centimeters is not the. Let me come back to yours so to make sure I have it. Okay, so 8 centimeters, 30 degrees. All right, which means it's bisected 15 degrees, 15 degrees. So what we have to do is we have to look at the. I don't know if we have enough information for that, do we? Shoot. Centimeters, that means this is 8 centimeters. Right. 75. We know this is 75. And we know this is 75. Okay. Now, what I could do is I could kind of, I guess, do an approximation. Which means if a 90-degree angle eight. Alright, let me find. I have one of these. Alright, go Kate, man. I haven't seen these in a while. and thickness. The only thing is, normally they would give you a thickness here. And, alright, what's the question? Sorry I missed it. I'm trying to think was a better fit. Oh, yeah. Alright. If the mechanical advantage is 2, it was 2. Okay. I'm gonna have to do some research on this one because let me see. You sent me another email. Hopefully, this will in the same question. Yeah, Kate, I'm gonna have to do a video. Yeah, the base by the altitude. Okay, but the thing of it is this is not the height. This is the height. And we would need to at least know the base. So that's like another weird question. But yeah. Alright, so I'm going to review the stream and I'm going to get back to you guys with this one. Let me see, and okay, we have 2 tanks that have exit tubes or openings with the same cross section. Alright, and the inch with the volume of water be exiting greater. I'm not sure distance would even have an effect on it. So, Kate, we'll do research on that question. So we have 2 identical containers, and I know my drawing's not identical, but the gist of it is that the cross sections of the pipe are the same, but one pipe is longer than the other. And they're asking through which opening will the volume of water exiting be greater? Water level. The atmospheric pressure is going to be the same. I would say the shorter pipe, because it has less length to go through, and the shorter pipe is going to have more the air rushing in quicker to kind of equalize, as opposed this is going to take longer. I would even venture to say that this one may empty out a little bit quicker as well, because the length of the pipe is shorter. The air is going to be, coming in to equalize and let the water out. So I would go, and that's just a guess, but when you click that, Mr. Velez, what do you volume of a cylinder question? Okay. Alright, we'll wait for Mr. Velez to get back to me on that, but that is my assumption. Shorter pipe, same two containers, shorter pipe. Water is going to be coming out, I think, a lot quicker in this situation, because this situation, the air's got a longer path to equalize and let air in for it to come down, where this will be a much more rapid process. Let's repeat the tank question. All right, the tank question. 2 tanks have exit tubes of identical cross sections situated at the bottom and at the bottom of their right-hand side panels. So the cross section, the tube, like this would be a 3-inch pipe coming out, and this would be a 3-inch pipe. As when I'm saying 3-inch, I mean like the diameter across the pipe if I held it and turned it towards the camera. But the only thing is the lengths of the pipe are this is longer, this is the short one. All right. So the question is asking, through which opening will the volume of water exiting be greater? The volume. All right. So cross section is the same. The volume be greater. I don't know. That's another one. I normally don't get questions like these two. Kate, I don't know if Kate's question did not have enough information or not, but she took a picture of the whole thing. And this one too. I'm gonna research. I'm gonna do a follow-up video with Kate's question and this one. And I have one for you, Sierra. I haven't forgotten you that one. And all right, we'll move along. All right, we have 15 minutes. Oh, there is no number. There is no number to solve. Not sure your question, Navy lady. All right. You did ask me to do a volume of a cylinder question. All right. Volume of a cylinder question. What is a cylinder? A cylinder is, actually these tanks might be cylinders, okay? But a cylinder is, if we chop this off, this could be a cylinder. It has a circle straight up, and it's a circle. So when we talk about the volume of the cylinder, we're talking about the area of a circle and height. That's what we're considering, or the length of something. So let's take one of those pipes. Let's say we had that 3-inch pipe, and let's take in account the volume of both of those pipes, because one pipe was longer than another. So the diameter across here is 3 inches, and we'll take a second pipe. We'll make it longer. We'll say it was 6 inches. Okay, now, just to be clear, the area of a circle is pi r squared. The volume of a cylinder is the height times pi r squared. So if you look at this, we're going to have the circle that we're talking about. This is the area of a circle. So if we just had a circle and we wanted to know the area of that circle, pi r squared. So now the volume is using this, and it's just using the height as another component. So we'll say this is 6 inches and this is 3 inches. So what we'll do is we will compute the volume of these two cylinders. All right. So in this case, we don't have to deal with r squared, because we have well, actually, yeah, we would have to deal with r squared, radius squared. All right, so the radius, the diameter is 3 inches, so the radius is equal to 1.5. the radius in this system is 3 because it's 1/2 of the diameter. Actually, no. They're both 3. This is just 6 inches long. This is 3 inches long. I'm sorry, shorter pipe. So it's the same in both. 1.5. The thing is, when we add the height, this is going to be 6, and the top one is going to be 3 inches in height. All right, so pi r squared. Pi is equal to 3.14. Radius is 1.5. And we would square that. 1.5 times 1.5. That's 15 squared. 225. 225. 2.25 if we square that. Alright. R squared. 2.25. Alright. So in this case, the pi r squared is going to be the same. It's going to be 3.14 times 2.25. Alright. And then when we get those numbers, we multiply by 3 in this case and 6 by that case. Alright. So, help me out, guys. Give me, somebody calculate 3.14 times 2.25. But it says neglect the length of the pipes. Hold on. About the same number of the pipe. Alright, let me look at well, I didn't, this is not a question unless somebody sent a question. I'm just doing the volume of a cylinder because Navy lady asked me to do a volume of a cylinder question, but it says neglect the length of the pipes. You can't neglect the length of the pipes. And let me just fact check myself. Because sometimes I'm, you know. All right. So, yeah, moving on, yeah, you can't, the volume of a cylinder, it is radius, you know, you're gonna have to use the pi r squared, and you're gonna have to multiply the height to find the total volume. It's kind of sort of like, finding the volume of a solid. Alright, we would use what to find volume? Length times width times height. So we're kind of packaging or incompetent calculating everything, the whole of it. So this is a cube, which the volume is length times width times height. Now with circles it's kind of different because it's a curved surface, number one. So we can get the length, but the width and the height are not easily measured because we can't specifically use those parameters to, you know, length and width. We still have a whole lot around here missing. So that's why we use the area of a circle formula in order to calculate the area of a circle and then the length of it. Alright, so moving right along, if we take and can't you use 222/7 for pi? To me, ever since I've been to school, pi was equal to 3.14. Now 22 divided by 7 may be 3.14. That might just be the fraction form, and I will look at that in a second here. Let's see, 22 divided by 7. Yeah, 3.1428, blah, blah, blah. Yeah, so that's just, Navy lady, that is just a That is just a fractional form for 3.14. 3.14, or what did you say, 22 over 7? Because every fraction is a multiplication and division problem, so to speak. If we divide 22 by 7, you're going to get 3.14. Alright, so let's continue with calculating the volumes of these. So, Joe got 7.065 for the pi times radius squared, and then all we have to do is multiply that by the heights in these cases. So this would be 7.065 times 3, and this would be 7.065 times 6, and that will give you your volume. All right, and okay, 21,195, and the second one will be Alright, 42,390,123. Alright, 42.39 will be the volume of the second one. Alright, it's an approximation for pi. Yeah, it's an approximation. We will have to use computation where they keep pi in the answers. Normally they would keep pi. Pi is an approximation, but whenever I'm using pi, 3.14 automatically is what I would use. So here we discuss area of a circle, which is pi r squared, and we talked about volume of a cylinder, which is basically area of a circle times height. In this case it was 3 inches, in this case it was 6 inches, and we came up with 21.19 and 42.39. Alright, everybody hit clear if they got it. Again, if you need this slower, this is DVR, and you can come back and look at it. Okay, I have Kate, I got a research problem on that one. I got a tank research problem. There's like 6 minutes in the stream. So I guess what we're going to do is we're probably going to just, unless you have some really, really quick questions or whatever, if we got some really, really hard questions, and I haven't seen questions like that in a while. Kieno or anyone know anywhere I can find another ASTB practice test? I want to do another, but I've already done both in Barron's. Alright, Jay, I'll send you one. Which is the Which of the following is a factor of... Yeah, try Air Warriors. Thanks, Thomas. 6x to the second power. I can do this one. Now, this is factors. This concerns factors. And I'm going to give you guys a really cool, quick method. That's a very evil question. And you have 6x squared minus 13x plus 6. Now, what we're going to do is, how do we come up with this? We FOIL to come up with this. Alright? We FOIL to come up with this. So, I got to look at factors of 6. Alright, so we have factors, we have 1 and 6, 6 and 1, 2 and 3, and we're multiplying these guys. 2 and 3, alright, and 3 and 2. Alright, so those are factors of 6. Same here. So I'll flip these. If I put 1 and 6, I'll put 1 and 6. And then I'll put 6 and 1. And then 3, 2, 2, 3. These are factors of 6. And these are factors of 6. So these are the, what I would call F, L, and FOIL, because ultimately what we did was we FOILed. So now I got to look at the opposite and inside numbers when I compare these and see if they add up to 13, which is here. Alright, so 1 and 6, 1 and 6. What are the opposites? 1 and 6. So opposites, 1 times 6 plus insides. 6 times 1. 1 and 6 is 6. 6 times 1 is 6. Does that equal 13? No, it does not. So now let's play around with this. Alright. This is not going to work, I don't think, because this will be 36 already. So that's too much. Now, let's look at, we need something that's closest to 13, which would be 2, 3, 2, 1. Alright, opposite 4 and 9. I like this. 3, 2. Alright, opposites in this case would be, if we use these two factors here. Alright, so the opposites would be 2 times 2, and the insides would be 3 and 3. I had something here. I was thinking 2, 3, 6, 4 and 7. No. 9 and 4. 3, 3. 3 and 3. 9. Alright, so this might not, these may not be the two. Alright, opposite 3, 3, and 4. Alright, sorry about that, guys. These are the ones. Alright. Alright. These two. So my opposites are 3 and 3. 3 times 3, which is 9, and my inside factors are 2 times 2. 9 plus 4 equals 13. So this works. So I found my factors. Alright, so how do we do this? We looked for factors of 6 here and 6 here. But we have to arrange them so that when we opposite inside, when we multiply those terms and then add them, they have to equal to 13. So my terms are the outside, which are, and I'll put my little brackets here, my outsides, which are 3 and 3. Alright, so 3 is on the outside here, 3 is on the outside here. My insides are 2 and 2. So 2 goes here, 2 goes there. and it is going to be a X here, a X here, and minus signs. Now, we have to test it out. So, this is the original problem. And our answer that we came up with was 3x minus 2 times 2x minus 3. Alright, so when we take the first term, we get 6x squared. We go to the outside terms, we get 9x, actually negative 9x. The inside terms are negative 4x. And the last two terms, negative 2 and negative 3, is positive 6. So we have our 6x squared, check. We have our negative 13x, check. And we have our positive 6, check. Alrighty. And Jay, worked it out, super quick. Okay, let me know how it goes. I'm planning on taking a test. Check out my vids tomorrow. I was posting some vids of me studying for the ASVAB. Check out my vids. Okay, thanks, Navy Lady. I will definitely check them out and subscribe as well. Okay. Alright, so it's 11:01. If you guys need tutoring, I'll repost my just send me shoot me an email if you guys need tutoring. I thank all you guys for showing up. And Navy Lady, if you do ASVAB videos, you should you should do like a live chat like this, like on a Google Hangouts or something like that. I'll definitely check it out because it's all about just exchanging information and asking questions and seeing the tests, be it SIFT, ASVAB, ASTBE, or AFOQT from different views. Okay, Jay, I hear you, buddy. What was my question? Or what was I going to say? So I'm here every Friday night, 9 to 11, for you guys. Bring your, congrats, Navy Lady, doing your ASVAB next week. Also, come back and let us know your experiences, what you saw on the ASVAB Kieno for Sunday. I will have to move. Is it possible? Okay, we'll talk about that. I'll shoot you a Skype. I have you on Skype. Also, I am Kieno.Thomas on Skype. Okay. And, yeah, good luck. No problem. They changed your schedule. No problem. So you have my email. You have my Skype contacts. If you haven't already liked, please like. And we'll close right there. I thank you guys for watching. Please, I'm sorry, I'm reading. I got distracted. But I'll say good night to you all. See you guys next Friday. I hope you all will attend. If you have recruiters or whatever, just tell your recruiters, hey, check this guy out. Check out and join in. Kate, Sierra, and William, whoever gave me that super hard question. I'm gonna do some research on these things and make sure you guys are subscribed to me because when I put out the video, you guys will automatically see it as it's published. So again, thank you guys. I'm signing off in 5, 4, 3, 2, 1. Okay, my encoder. There you go. See you guys next Friday, 9 to 11 Eastern.